Welcome to the lair of the Batty Boffin.
Hi there Batty fans, time for a little bit more all about optics, and we're doing some more colour mixing today. Now, in an earlier video I looked at some of the things in experiment number 13, and there's a downloadable project sheet for that at www.battyboffin.co.uk. Pop along there, and experiment 13 has got some lovely colour mixing things all to do with these kind of filters. Now, these are actually proper optic filters that they use in stage lighting, but you can just use bits of coloured film. You may have to, I'm very sad to say, eat a lot of posh chocolates in order to get the cellophane wrappers, but it's all in the name of science, so do persevere with it. Now, in the last video we looked at some of the interesting colours mixes you can get, particularly if you have two torches. I've got my little light box here, and we can mix two colours together. For example, we have blue and green, making that nice cyan. Here's a close-up of it. And of course, the surprising one that most people don't expect is red plus green, which makes yellow. I'll just move my lights a little bit there. I've got a bit too much green in there. There we go. There's some yellow in the middle there. Here's a close-up of it. Now, this is what's called additive colour mixing, where we're taking a green light and we're adding it to a red light and getting yellow light as a mixture. But there are actually two ways of adding light. One's called additive, like this, and one's called subtractive colour mixing. And the subtractive colour mixing is the kind of thing that you get in paint, because with the lights, if you mix all the lights together, if I had three torches and did a red and a green and a blue, I'd end up with white light in the middle. However, if I mix all the paints together, I'd end up with black. And here's why the two are different. It's all to do with what a filter is doing. This blue filter here is taking white light coming into it, and it's letting through only the blue light. So white light goes in and only blue light comes out. All the other colours are absorbed. So this absorbs the red light, it absorbs the green light, it absorbs the purple light, it absorbs the yellow light. It only lets through the blue light. This filter only lets through the green light. So what this is doing is taking away everything but the blue light, and this is taking away everything but the green light. So if I put the two on top of each other, what comes out the other end? Well, you have a think about it and then watch this close-up. So, if I put the two colours on top of each other, I'm first of all subtracting everything except the blue light, and then I'm subtracting everything but the green light. But of course the first filter only let the blue light through, so there wasn't any green light to come through the second one, so what you come out the other end is nothing. Black. So when you take away the two, you end up with black. On the other hand, if I do them with the two torches, I'm adding them. This one is letting through all the blue light, but nothing else. This one is letting through all the green light, but nothing else. But of course, because I've had blue light come through and green light come through, I can add the two together and get the cyan out of the end. So when you add blue plus green, you get cyan. But when you mix them with the subtractive colour mixing, you get black. Now, paint works like the subtractive stuff. Although the paint doesn't transmit like this, what it does is reflects it. So a blue surface, for example, oh I don't know, this cushion, the surface of that will reflect only blue light, and it won't reflect any other colours, it absorbs all the others. And an orange paint, or something with an orange surface, will reflect only the orange light and absorb all the others. So if you have some blue paint, which absorbs everything except blue, and some orange paint, which absorbs everything except orange, and mix the two together, what you get is, well, it should be black. It's usually a sludge, to be honest, because all the colours are being absorbed. The blue light is being absorbed by the orange paint, and the orange light is being absorbed by the blue paint. And it works in the same way as putting two filters over the top of each other. I haven't got an orange filter here. What would we got? Let's do magenta. And what's a colour that's got nothing to do with magenta? Green. Okay. Magenta is a mixture of blue and red, and green is nothing to do with it. So if I had magenta paint, that absorbs everything except magenta. And if I had some green paint, which absorbs everything except green, and mix them together, what would happen? It's the same thing as if I put a magenta filter, followed immediately by a green filter, and then shine a light through it. You have a think about it, see what would happen, and then watch the close-up. So, in subtractive mixing, they make black. Question is, what happens in additive mixing? So if I have one light shining green and another light shining magenta, and I mix the two, what will happen? You have to think about that. We get a patch of white in the middle. Here's the close-up. So when we mix opposite colours by adding the lights, we get white. When we mix opposite colours by adding the paints or combining the filters into one, we get black. One's additive colour mixing, the other's subtractive colour mixing. Here's another set for you. Let's have cyan and red. These are opposites. Cyan is made from green and blue in the RGB, and red is the opposite one that's got nothing to do with green and blue. So what will happen if I mix cyan paint plus red paint? What would happen if I put a cyan filter and a red filter on top of each other? And what will happen if I mix a cyan light and a red light? Okay, have a think about those. Well, here are the two filters. Red and cyan, the middle bit is black, and that's what will happen with the paints, although in real paints you get sludgy brown. And here are the lights. A red light and a cyan light. Here's the close-up. So, white light in the middle, because the cyan is sending through all the blue light and all the green light. The red is sending through all the red light. The red plus blue plus green makes white. It's clever, isn't it? And that is in fact how the things on your computer monitor work. They have things that send out red light, things that send out blue light, and things that send out green light. And the combination of all of those three lights makes white. On the other hand, if you had paint and mixed all three, you'd get black. And in fact, if I try looking through that, yeah, I can't see a thing. A couple more for you to try. I'm going to use some of these ones here now. I rather like the colour wheel they make. So, what would happen if I put a cyan filter in front of a yellow filter? Or if I mix cyan paint plus yellow paint, what would I get? Well, let's have a look. Cyan plus yellow, green. And that's how your printer works with these cartridges, because the inks from these are quite transparent ones. They're not solid ones like inks. They're transparent ones, and they work just like this. So a spray of cyan ink plus a spray of yellow ink makes the paper look green. So what colours of cyan, yellow or magenta, what colour would you use to get red on the page? Remember, there's no red ink in here. There's cyan, yellow and magenta in here. So what would you use to get red? See if you can work that out. To get red ink, you would mix yellow ink plus magenta ink, and that would make it look red. Okay, so that's a little bit about subtractive colour mixing, which is the way that the inks in a printer work, or putting filters on top of each other, or paints, and additive colour mixing, which is when you get a beam of one light and a beam of another light and you shine them both and add them together. Hope that's a bit of fun on there. Get some of these, get some torches, have a play with them. It's great fun. See you next time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!